my band will go.
Yeah, and you're black.
Yeah.
Perfect.
Good
Welcome all for coming.
viewings. Tried to match too.
We're gonna get started, but make sure there's coffee and some water and some snacks in the back, so help yourself. And we'll try to keep today pretty informal, so if you have any questions at all, don't hesitate to ask. Bathrooms are just down the hall, kind of right where you come to the stairs in that open area. And yeah, we'll kind of start out in the classroom in here and give a little overview of what we're doing. And then we'll go out on the dock and do some tests together so you can see all the different steps. My name is Marie Schmidt. I work for University of Idaho Coeur in our Community Water Resource Center. And maybe if we could just all go around and introduce yourself. If you live on the lake or a bay, if you want to tell us where you live, and maybe what your, if you have any background with any water science, that'd be great.
Barb McFarland, no background in water science, and we have a cabin up on Ponderay on Elliott Bay, just north of Garfield Bay.
Bob McFarland, same info.
Except science.
More science, though. It's a lot more science. Tell them who your professor was in biology.
Well, in college it was George Wald, who was a Nobel Prize winner.
Yeah. Little science.
Got me interested.
Minor distraction.
And what did you win the Nobel Prize for?
Well, medicine and physiology, but he dissected about 10,000 frog eyes and elucidated the chemistry of vision.
Wow.
Wow,
So he wasn't a friend of frogs exactly.
But there's Bob's science background.
Ron Lawley, I overlook Cougar Bay, and a little water experience of just being on the lake or tending to an indoor pool, so checking the chemicals.
Courtney Green, just really curious about the water in the area. Swindled in.
Well, and Courtney has more of a history there. She's a teacher, fourth grade teacher, and she's actually on her way to Dalton, Barb.
No, that's,
Oh, where are you going?
I'm going to Atlas.
Atlas.
Kelly's
That's
going.
right. Okay. So the fourth grade teachers, and they have been bringing in their fourth graders for how many years now?
Six, I think, yeah.
6 years, and we do this water science with them. And so this was an opportunity for Courtney to see it in an adult version of what we do with kids.
I got the adult version of the wastewater treatment plant this summer, and I was like, whoa.
That's not a lot of fun.
I was interested, but it was way over my head.
Heather Boldy, I live on Moscow Bay, Coeur d'Alene Lake. Little bit of YCC camp when I was a kid.
Perfect.
I mean, I had a lot of fun. So we did water and all kinds of stuff. Not a big science, not no Nobel Prize.
Not necessary at all.
I'm Frank Wahom. I'm at the Moscow campus. I'm a limnologist, so water is my life. Working up to the Nobel Prize.
Hang with Bob, hang with Bob.
Break out the fish eyes. Good morning, I'm Rebecca Stevens with the Coeur d'Alene Tribe. Hi, Courtney, nice to meet you. And I represent the tribe in the Superfund cleanup as well as natural resource damage assessment work.
And I'm Steve Wilson from the Coeur d'Alene Chamber of Commerce. I live in Cave Bay, and 100% of my experience I've learned from Marie, Rebecca, Jim Eakins, and Laura Lamatia, and Jamie Bruner.
Jamie.
My name is Amy Anderson. I'm with Kootenai Environmental Alliance. And although I wasn't hired to do this, I find myself in the position of trying to run and get their Waterkeeper program together. And part of it is we got a little bit of funding to start a citizen science water quality monitoring program. So I'm kind of trying to shadow as many entities that are sampling and doing any kind of monitoring on the lake or in this area in general. So that's why I'm here.
Sherry?
Hi, I'm Sherry Nowak. I work for U of I. I'm the community development specialist. So I'm just I'm new to the office, so I'm just listening in today. I do some grant writing and all that stuff for all of our programs. So any background information in case we need some money. I'm your girl.
You might be more familiar with Sherry in her role as starting the backpack program. So Sherry is one that started the backpack program that goes home with kids who don't have food over the weekend and over long vacations. She's coordinated it, starting with how many backpacks?
16,
And now you're at,
450 a week.
yeah,
Yeah. And going on our 10th year.
yeah. So we're retooling her.
Yeah. Yeah.
But you're not losing, you're still keeping your hands on the backpack
Yes, I
program.
am. Yeah.
Jamie.
Good morning, I'm Jamie Bruner. I work for the Idaho Department of Environmental Quality as their Coeur d'Alene Lake Management Coordinator. So water is a lot of my life too.
Thanks everybody for being here. Like I said, it's not necessary to have any experience. We just like to see where people are at. Hopefully today will be a really good intro. Someone who came to one of our Baywatcher meetings about a year ago, we did some just very intro to basic lake science materials, and so we're going to go through more of that today and probably more depth than we went into last time. So hopefully you'll get to learn a little bit more how our lake works and some of the parameters that we study when we go out and do these water quality monitoring programs, why we test for the things we test for. So like I said, feel free to ask any questions, grab some coffee if you need it, and I'm going to pass it off to Jamie to give a little introduction of the Department of Environmental Quality's their citizen science program called CVMP.
So CVMP, Citizen Volunteer Monitoring Program. I don't know exactly what year it started, but it's about 30 years in the program now. And it used to actually have funding from the state, now it doesn't, but we try at the regional office level here in Coeur d'Alene to keep it running because we have so much water and not a lot of people. So, and there's a lot of people out there that are interested in water quality, and so they developed this program to pair up people who are interested and able to go out and do sampling with our technical resources. And so this is the quality assurance project plan that anybody who participates in CVMP follows this. It kind of lays out how we make sure our samples are collected right, handled right, delivered to the labs right, and then we get good data that we can use. So I don't really have anything more formal to talk about other than that, unless you have questions about it. But essentially what I'm saying is that as long as we're following this QAP, DEQ can use the data that will be collected by citizen volunteers.
Is that online?
I can probably put it on our lake management website. That would be good to have it online.
So currently, do you know how many lakes are being monitored in North
I
Idaho?
don't statewide. This is the North Idaho QAP because, like I said, at the regional office, we've been trying to keep it going. I believe Twin Lakes is still doing it. Spirit? Is Spirit? Okay. Spokane River was. I think they're still looking for a replacement volunteer. They've been doing it for a while. Kokalala. Hauser, I'm not sure if Hauser's still doing
Priest.
it. Priest.
Yeah, Hauser is.
Renan.
So that's 6, 7.
I know I've looked at it, but can you remind me what parameters are covered in that QAP?
I think I'm gonna go through all of that.
We will go through most of them today. The only ones that we are not testing for through our Baywatcher program.
So we have the Secchi disc, chlorophyll A, total phosphorus.
So the only ones we're not testing for that they test for is chlorophyll A and total phosphorus. Do you have that in yours? Okay. So chlorophyll A is a measure of basically the plant, the photosynthesis is happening through the plants because you're measuring how much chlorophyll is in the sample. And for that, you have to send the sample out to a lab and have them analyze it. And so right now we do not have funding for that, but it is something we're interested in the future because Coeur d'Alene has a lot of plant growth in it, and we want to see, especially what we call the phytoplankton, the tiny little plant-like plankton that are more commonly known as algae. We have a lot of that, and we want to quantify how much we have. So that's something we're interested in Coeur d'Alene. And then total phosphorus is also really, really important in our lake system. We can talk about that too, about why that's important. But again, we have to send it off to a lab and have them analyze every single sample. And right now we just don't have the funding. So it is something we're hoping to add in the future. Otherwise, our protocols are going to be pretty much the same as the citizen science volunteer monitoring. So we'll go into what those are.
And on Coeur d'Alene Lake, if we have a site where we're going to have some long-term monitoring by a citizen volunteer, we can talk about funding those things, because we go out and monitor sites on Coeur d'Alene Lake several times a year, 9 times a year. It kind of depends on spring runoff events. But what we don't have resources to do is have long-term monitoring sites at the bay areas. So we can certainly talk about that.
You need it in the winter also. Oh, they do. Need it in the winter also.
Yes, we typically go out until about the first week of December, sometimes a little bit later, just to get some samples after the lake is kind of mixed again. But then we don't go out again until like a spring runoff event. So with the bays, I think probably the growing season would be sufficient, but more data is always better.
Marie, chlorophyll A is really important in the tribe samples also on the lake. It collects chlorophyll A and total phosphorus, as well as the lateral lakes on the river. Do you think if there was funding for U of I, would this lab be able to do that analysis? Or is that a question for Frank? Like, what are your thoughts on?
Right now, we do not have the equipment.
Well, Frank, could the lab on campus do it?
Sure, you can do it right here. You have a spectrophotometer.
Well,
So you just need someone to do it.
Oh,
Need a body.
need a body?
to do it. It's relatively simple.
So I should clarify that with DEQ's monitoring, if it's north of the tribe's reservation boundary, that would be our jurisdiction, but the tribe has water quality jurisdiction south.
yeah. So there's
But then you want a approved lab for the data to go into your database, right? Yeah, so we have to send it out to a lab.
And there's one locally that we've been going through SVL. They have an office here and they ship the samples over to Kellogg for analysis.
So I guess it's important to clarify that there's a couple different tiers of monitoring going on. So on Coeur d'Alene, the tribe and Department of Environmental Quality share responsibility for the lake, and they monitor different portions. So the tribe monitors the lower half, lower third, and the state monitors the upper 2/3. And they go out to the same sites regularly year after year and test for very similar parameters and some additional ones as well. And then they sometimes go to different sites, but again, they're kind of limited in their time and resources to go into the bays. So that's where our Baywatcher program would come in. And then the citizen volunteer monitoring program that Jamie was talking about is on other lakes in the area, so not on Coeur d'Alene, but on the smaller lakes. And so we saw the opportunity to take that program as it existed and kind of incorporate that into Coeur d'Alene to help out the tribe and DEQ with their data. Because we want to have, again, as much data as possible.
Reliable data too.
Yeah, and if we have volunteers who are going out regularly and we know that they're following these quality assurance protocols and we can establish some trends over time, that's where then we can go to either the tribe or the state and say, hey, here's some things we're seeing. You may want to consider doing more intensive monitoring there.
Marie, is this something that the EPA could potentially, if they would make a administrative ruling, is this something that they could pay for the labs? It would seem like it would fit into an equation that would say, hey, we're monitoring, and this is, the oxygen cap is important, and here are 2 ways to monitor it, and they ought to be able to fund that. Is that a possibility?
Anything's possible. It's the funding source. We've been told they will not use the Superfund pipeline money because they deferred a remedy for Coeur d'Alene Lake. So, which is problematic. We are looking into the work trust settlement dollars that are privately invested that EPA directs, and we'll keep applying pressure there. There are other programs that EPA has, like through Clean Water Act, but funding streams are really, they're limited, they're tight, the application process is, you hear one day these funds are available and it's like due the next, week or something like that. So it's been problematic. All right, I answered for you.
No, that was perfect. I think that there are potential sources for funding for this via grants, or potentially if we can identify people who are on bays of, maybe high concern, the state may have some funding. And so I think that that's definitely a likelihood that we'll be able to test for those in the future. Just right, getting started, I think we'll start with the ones that we can go out and test for that day, and then go from there.
Build a track record so that there's some credibility.
Yeah.
Is that kind of part of the,
Yeah.
okay.
Long-term trend.
So if I do this in K-Bay, don't screw up, is what you're telling me?
Right. Pressure is on.
Do it right? Okay.
So how much money are you talking about to have a lab that
So phosphorus, I think, is about $40 a sample. I don't know the cost of chlorophyll A.
So over the course of a year, if you were able to do this, how much money would you need in your budget?
So our goal is to have people go out and monitor once a month from about April or May through about September, depending on the person and what your abilities are. And so.
So
Six months.
two samples per.
Mhm.
6 months.
2 samples per site, and then about $40 a sample, and then time per day. So it's.
We can, if you want that information, I have a table that was just sent to me by our limnologist with all those costs broken out, if you'd like to see what that looks like.
Yeah.
It'd be nice
I'd
thing
love
to
that
figure out
too.
who to ask
Okay.
for
Yeah.
money.
Yeah.
Have it amount.
And nice, yeah.
We're just contacting the lab to have cost as well, like as we can go online.
Right, yeah.
It's not too terribly much. I mean, it's definitely doable.
I'm not sure about chlorophyll off the top of my head, do you?
It's gotta be cheap.
I have it from Dale, and he just sent me the email, so I'll pull it up.
Yeah. Okay. So, yeah, I guess we just wanted to let you know that this was the basis of this program, is the Citizen Volunteer Monitoring Program. And so we're not reinventing the wheel, we're using something that's already in existence, but bringing it to Coeur d'Alene Lake, and some of those smaller bays where we need a little bit more feet on the ground and feet in the water and see what's happening there. Okay?
Yeah, and even if you are at Lake Pend Oreille, any of this information I think will be valuable for the state.
Yes, that applies to all of them.
Yeah, and currently there's no volunteers on Pend Oreille either, because again, it's kind of designed for those smaller lakes, the outlying lakes, and so it might be good to get a volunteer on Pend Oreille too. Okay.
Who studies Pend Oreille?
The state of Idaho.
There are a couple of folks in my office, Kristen Larson and Bob.
So you they have to have somebody on.
Yeah.
Yeah.
And then there is another citizen science program up there, the Water Keeper, and they do some water testing as well. And I'm not familiar exactly what specific things they test. I know they test similar parameters with some sort of different methods.
And how about the tributary rivers?
That would be Kristen Larson as well.
Are you talking tributaries?
Like rivers and angels.
Of Pend
There are
Oreille.
different people that
Right.
kind
Oh,
of
yeah.
lead different areas. We have people assigned to.
But everybody, there's data coming in from everywhere.
Yes, but not as consistently as on Coeur d'Alene, because it's a unique situation in Coeur d'Alene and then
Yeah.
superfund site. They kind of go on a rotation, moving around depending on what the TMDL schedule is. Water body, like with that, impaired list.
Any questions on any of that so far? Like I said, we'll go into all of those parameters that we'll be testing for in a lot more detail. Okay, with that, your turn.
My turn.
And the remote's working.
The remote's working. Great. Okay, so Marie said a good precedence this morning in terms of keeping it formal, even though I'm in my natural element of lecturing. Just make sure you slow me down, and I don't pummel you over the head with too much information. So, and forward is which button?
The button on the right. Maybe. Or maybe, let's see.
Left. Okay, there we go. Yeah, right. So I just give you a quick outline. So I have about 20 slides, and they give me an hour. There's no way I'm going to take an hour. but maybe I will. So I was requested to provide some background information on the parameters that you measure as part of the program, and then how they contribute to our understanding of the lake and then of water quality in general, so that you have an understanding of why you're measuring temperature and the other parameters. So the parameters that are of interest are temperature, dissolved oxygen conductivity, the pH, and Secchi depth. And so the rest of what I'm going to talk about is why we're interested in those parameters and what they add to our understanding. So start off with temperature. I better stand up here, right? So if you think about temperature, you can think of that as being the metabolism of the lake and the system in general. So we're warm-blooded, right? Our body is at 37.4 degrees, and that makes us special. All the animals that are out living in the lake are cold-blooded or poikiliotherms. So their metabolic rate is exactly what the lake temperature is. So that's why I say that the metabolism of the lake is controlled by temperature. And then if you think about chemistry, right? You cook an egg, the hotter you make it, the faster it cooks. And that's exactly the same thing in the lake. The hotter you make the lake, or the warmer it gets, the faster things go along in terms of the metabolism that occurs in that lake. Usually flip this down that way I can see you guys. Okay, so if you think about in terms of the rates, there's the biological rates. So you have fish, they're cold-blooded. You have the algae, the zooplankton. All of those rates and those little critters that are out there are going along at the environmental temperature. So if it's cold, there's not a lot happening, right? If you think about winter, it's 4 degrees, not a lot going on in the lake. Now get it up to 18, 20 degrees, you want to go swimming in it, right? It's nice and warm, and the critters are moving along at a much faster rate at that temperature as well. If you think about chemistry, this is the cooking the egg. We have a lot of chemical reactions that occur in the lake. The warmer it is, the faster they go as well. And then there's the physics of it. And this is the mixing and the water movement, and then we get that nice layering that occurs. You jump into the lake, it's warm on top, you dive down, it gets colder. And that has huge implications of how the lake is structured and how the bays are structured, and I'll get into that in just a second. Right now. So if you look at the lake in summer, the warm temperatures are represented by the red, and then you move through, and then you get into the bottom of the lake, and it's nice and cold. And if your bay is deep enough, then you will get this sort of stratification, and we call this stratification. It's layering of the water layers. And here's the profile. So limnologists have a funny way of putting graphs together, right? So the air-water interface is up here, and that's 0, and then the depth increases this way. So it's like cutting a lake in half. And then temperature increases along the x-axis on top like this. So if you look at this, this makes sense, right? It's very warm at the top, and I exaggerated here at 30 degrees. You're never going to get a lake around here at 30 degrees. I think you get around 20 degrees Celsius, 68, 70, 72 Fahrenheit, right? Is that about right? For you guys are on the lake all the time, so. It's swimmable, it's nice. And then you come down, and that's defined as the epilimnion. So that's the top part of the water column. And then you get down through this temperature change, and that's called the metalimnion. And that's where we have this inflection point, and that's the thermocline. That's where you get the most rapid change in temperature as you go through the water column. And then if the bay or the lake is deep enough, and you're far enough north, then that will drop down to 4 degrees Celsius at the bottom of the lake. Here, you're going to be around 8 degrees, 8 or 10 degrees. So if you go out fishing, that's where you want to hang your beer. Right? You want to get it into this layer. You don't need a cooler in the boat. But, so what happens then is because of physics and warm liquids are lighter, that warm layer floats on top of this colder layer. And so the bottom of the lake and the bottom of your bay will be isolated for the duration of the summer. So while that lake is stratified, this presents a cap to the lake. And there's if you get wind blowing across here, then the top will start to circulate. Like if the wind goes left to right, the water will start to circulate this way. And then on the bottom, the water will actually circulate the other way. Because on top here, the water comes down, comes like this, and right here it rubs, and it drags the hypolimnion with it. When it gets over here, it can't come up, so it goes down. So you get two opposite rotating currents if you have wind for long enough time on the lake. Okay. Yep.
Frank, the depth necessary to have full stratification is what?
I would say about 12 meters, yeah, 45 feet, 40 feet or so. So Fernan is 26 feet deep, and it doesn't stratify because it's that bathtub that's oriented right along the axis of the wind, so it just rolls all the time. Any other questions on that? So that's basically the thermal structure that sits there for the summer, and we're just coming up to that now in Lake Coeur d'Alene. So if you look at what happens on a seasonal basis, then in spring, the waters just come out of winter. It's sometimes, some of the bays on Coeur d'Alene get ice covered, others don't. The main part of the lake doesn't get ice covered, so it's exposed to the air temperature all winter long. And it's nice and cold, and we call this isothermal. So it's the same temperature from the top to the bottom. And then when you get wind blowing across it, that entire water column mixes. Okay, and that's a good thing. One, it gets oxygen throughout the whole water column. And in spring then, as the water rubs on the bottom, it brings up all of the algal cells that were deposited, all of the resting eggs from the zooplankton, and brings them back up to the surface. And they see the light and they start growing. So that's what starts the lake in spring. And then in summer, this is what I just showed you, is we have the perfect layering, we have that cap on top, and then this is where issues come in. So the oxygen that's in the bottom here at the onset of stratification, the mass of oxygen in the bottom, is all that's in there that that lake has for the summer, for the duration of stratification. So there's a little bit of exchange of oxygen right across here, but if you have more consumption than you have input across the exchange, then you can lose that oxygen from the bottom. And that's, in Coeur d'Alene, that's a bad thing. And there are some pockets that are already going anoxic, or there's no oxygen at the bottom. I'll cover that in just a second. But this is basically what happens, is you get the top part of the lake. This is what we swim in, recreate in. It's nice and warm. It's well oxygenated. That's where the algae live, and that's where most of the things happen in the lake. Then you get into fall. You get the cold nights. That surface water starts to cool, and then it goes back to isothermal conditions, and the entire lake mixes. So we call these spring turnover and fall turnover, when the entire lake rolls and mixes. And then keep your finger on it. Come on. Yeah, screw this. This way. And then in winter, some of the bays actually get ice on them, and Coeur d'Alene doesn't ever freeze over totally, does it?
It
No.
has.
Used to every 10 years.
Every 10 years. That's what I've heard in the past.
Not anymore.
Not anymore, right.
Last 100 years.
And then
10,000 years.
right, and then there are some bays where you could actually drive your vehicles out, right? The ice was thick enough for that, so you could fish right out of your front door, right? And what we call this is a dimictic lake. That's the classification we give to that. So it goes through 2 cycles every year. That's where the di comes from, and then the mictic comes from the fact that it's ice covered in the winter. Okay, any questions on that? So that's the annual seasonal pattern it goes through. And what's really nice for us, if you're taking these temperature profiles, so you're going to take a temperature surface, then you're going to go down 1/2 meter to another temperature, and you're basically going to put this profile together for us. So you take a temperature here, and then you give us those data, and we call this a profile. Those data come in, and then we make those figures for it. And over the season, we can see how that changes. And then just in the last couple of years, when I've worked with Ben, I've had a grad student with the tribe. It's really interesting to see. This year we're about a month behind in terms of how it's warming. And then last year we were a little bit ahead, and then the year before it was even warmer much earlier. And that's dependent on how much comes in with spring runoff and then just how the spring shapes up. So just getting basic temperature profiles for bays is really important to see how they're changing from year to year. And for us to understand how that water structures and how it layers over time. And as far as I'm concerned, a really good temperature and oxygen profile are some really basic but really good data to have. Yep.
You say we're a month behind compared to what?
Last year.
Just last year.
Just last year, yeah. And that's because it's been cold. And then over in Oregon, where I have some other research that's going, where it's the same thing. It's about a month behind. We'll be even further behind with this cold spell we've had now. So we started seeing a stratification happening, and it was set up nicely. The thermocline was at 4 meters, so that's where the depth was. And I bet you all of that is gone after this week. It's unseasonably cold right now.
Frank, can I ask a question?
Go for it.
Maybe could you touch on the importance of sampling during non-stratification and then after stratification? And what delta we're looking at? Is it mostly that temperature and other chemistry?
Well, so ideally, I'd love if somebody could sit on the lake and actually get this and then get us the date when it flips. Okay, so for us, that's the really important part. It's when does that lake actually flip, and when does it start to fully circulate? Like, that's a magic date for us in terms of when this goes away. Because if you have any sort of lack of oxygen in the bottom and you start to roll this, you bring all this low oxygen water up and it has to re-aerate, and then there can actually be a dip there for the biota that's in the water column, and that's really important. And then if there's any sort of funky chemistry going on down here, all of that is reset by oxygen getting back into the bottom of the water.
So,
yep.
Maybe a follow-up question to that then. So for those of us that live on the lake and are in the water all the time.
Yep.
So in the fall, I mean, I can come pretty close to feeling. I can't feel a difference.
When you swim.
Is that?
When you're swimming, right.
Yeah.
Yep.
You know, if you're in it every day,
Yep.
you're gonna notice it, right?
You bet.
So that is a telling tale, so that would be a time, I'm making this up, if we're measuring once a month and.
Well, so once a month is nice, okay, that's where we're starting with. If we can do it every 2 weeks.
Okay, all right, that's what I'm gonna say, so if I notice it, then I can measure it, and then how long does it take, how long does that take? I mean, does it happen
So
within a week?
it'll cool.
Does it happen within
It'll cool, and you can start to see that profile, that temperature profile starts to, I should have drawn this out. I didn't want to pummel you with too much data. But what starts to happen is this starts to deepen and this starts to draw back.
Yeah.
And then at some point you get a big enough wind event and the whole thing just rolls. Okay, so it starts cooling off just naturally because you get the colder nights, the shorter days. You get less sun input, so less heating as you go into we're past the summer equinox. So we're on our way to winter right now, right?
So that for.
I know it's abysmal thought, right? We haven't even got to swimming yet, but
around here, that would be about September 20th.
About October or so. Yeah, the first part of October. Yeah, so end of September, depending how the summer shapes up. End of September, first part of October, probably second week.
And it's sooner in the southern end. It's earlier in the, there's usually about a week between when the tribe is going out getting their last sample session of the year. And then you go out and kind of follow their event and look for that mixing to happen.
Does time matter, or is it just be consistent when you?
What do you mean time?
The time of day when you collect your temperature?
No, because there's so much inertia, thermal inertia, it doesn't matter. You could do the profile at night. You might get a little bit of a dip at the surface if you do it at midnight or 2 o'clock in the morning, right? Just because it's been dark for a while. But other than that, there's just so much mass out there, it doesn't matter when you do the profiles. Okay, any other questions on temperature? Move on to the other important one then from the biological perspective, and that's dissolved oxygen, or DO, if we like to abbreviate it as DO. Okay, So again, it drives the biology and the chemistry of the lake. You have, so oxygen and gas will actually dissolve in water, and then that's used by animals. And they use their gills or some sort of structure to extract that gas out of the water and make use of it. So their gills are exactly the same as our lungs. There's oxygen exchange across the animal environment, and the animals make use of that oxygen. Okay, and then oxygen, presence of oxygen is also really important in chemical reactions that occur in the lake. If you have oxygen present, then you have the chance for oxidation. If you remember your chemistry back from your schooling days. And then if you have the lack of oxygen or minus oxygen, then you get into a reduced environment, and that sets up some wicked chemistry inside of the lake. And I can touch on that briefly. It's near and dear to my heart because over in Oregon, where we're looking at the structure of the lake, the reservoir over there, we lose all oxygen right below the thermocline. So it's like a layer cake. You have the epilimnion, the hypolimnion, and there's no oxygen in the hypolimnion for the summer. And we're already hitting anoxia at 1 meter off the bottom over there. So 1 meter above the bottom, there's no oxygen present. And that will slowly creep up and come right up to 7 meters in the water column. So this is the whole function of the lake management plan, is keep that oxygen in the bottom of the water. Okay, so the reason salmonids, and correct me if I'm wrong, but it's greater than 6 milligrams per liter for the state. Yes.
Tribe is 8, I believe.
Tribe is 8? Okay. And so these are the fish you hunt, the salmon, salmon, trout, kokanee. What else is in Coeur Lake? I said salmon. All manner of evil. I'm not a fish biologist. So they like high oxygen for that. And then if you get into your warm water fish, bass and carp, usually greater than 3 milligrams per liter they can tolerate. And so those are your warm water fish species, or ones that make it cloudy and live in relatively turbid waters. Okay, if you're talking to a fish biologist, those are your coarser fish. For some reason, trout and salmon, finer fish. Yes, exactly. Okay, so that's just the importance of the dissolved oxygen to the critters. And then in terms of the chemistry, it really has a lot of effect on chemistry. If you lose the oxygen out of the water column, and especially at the sediment-water interface, then there's a change in that state, and you go to a reduced state, and then it causes the release of nutrients and metals. There's a change in the valence state, and the metals cease to be bound to the iron that's at the bottom of the lake, and same with the nutrients, and they actually come into the water column in free form, in ionic form. And from the perspective of the nutrients, that's primarily phosphate that comes up. And then any sort of turning you get of that water layer, it brings that phosphate up to the surface. And at the surface, you have light and algae that are going, hoo-hoo, nutrients, and that's when you get your bloom. Okay. And then with metals, I don't think I have to go into that. You get arsenic, lead, and zinc and copper, and some cadmium that are released into the water column as well. One of the big ones in my opinion, is the arsenic, just because it's so dangerous in terms of getting up into the water column. Question?
What's the amount of milligrams per liter that allows metals to reinvigorate into the upper water column?
So that's an interesting question, because it depends on the redox potential at the bottom, but once you get below 1 milligram per liter, there's two things happening there. One, our oxygen meters have trouble accurately measuring below 1 milligram per liter, and then it's entirely unclear how and what the redox potential is at that point. So the accurate way of doing that is actually measuring ORP, and that's not something that we measure, and that's a whole nother animal. So the chemistry that occurs at the sediment-water interface is a very complex science. So I've actually tried to demonstrate it here. So you have oxygen present, here's your sediment, that's the water column. And then here's the lack of oxygen. So once it gets below 1 milligram per liter, then we see this internal, we call this internal loading. Because you have nutrients coming in from the inflows via the sediment, and then when that slows down in our western hydrograph, right, there's hardly any input in the summer. So the inflows stop, but then you get this wicked dynamic inside here. If you lose the oxygen, you can actually get so much nutrient coming up that that fuels all of the lake productivity. So all the algae in the lake. Coeur d'Alene is not, at this point, there are some pockets in the river meanders that are really deep that go anoxic. And then the whole Cougar Bay does go anoxic, right? You guys have
There's a deep hole right outside of Cougar Bay that does.
that goes anoxic. And there's some pretty wicked chemistry that occurs inside of that as a result of that lack of oxygen. You guys are up on Ponderay, so you're good. There's no productivity in the water column. It's really low productivity water body, so no issues there. So you can see if you have a lot of algae in the top of the water column, they're really productive. They will eventually die, and we call that planktonic snow, and that comes down and it goes through decomposition. And as that material comes down into the water column, it uses oxygen through the decomposition that occurs. And that contributes to removing oxygen from the deep part of the water body. So the more productivity you generate at the surface, the more stuff is going to rain down into that hypolimnion to take up oxygen. Hence the emphasis on reducing nutrient input and stopping primary productivity, i.e. the algal species from growing in Coeur d'Alene. Because I think there are some spots where we're right on the boundary of tipping that thing over.
And those are kind of byproducts of chemicals that are being put into the earth.
And well, so there's runoff. Put it this way, I don't like to assign blame to any one sector. It's human activity in general. Anthropogenic activity. We're very good at modifying the landscape, and the lakes are the bathtubs of the landscape. So everything we do on the landscape, once you put rain on it and you get runoff, it ends up in the bottom of the lake. So it's a sort of death by 1,000 cuts. Some of them being bigger than others.
So Frank, if I might just add.
Yep, go for it.
In the Business Journal, I just picked it up this morning. It was also on the front of the Coeur d'Alene Press. There are lots of factors, like Frank said, we don't like to point fingers, but this community is booming with development right now. So these homes that are right on the water's edge with no site disturbance setbacks. Yeah. But we're doing just fine economically.
And no enforcement of any regulations.
And no enforcement of any regulations.
Right, so there's...
Just had a jab a little bit.
Yep. There's an interesting dynamic here in Kootenai County. Especially with your commissioners. It causes some head scratching in Moscow. Especially in the limnology lab. You know, removing setback boundaries to zero and things like that are interesting. Okay, so oxygen, if you are out there, you're going to have a meter, you're going to measure temperature, and you're going to measure oxygen. Those are really two important parameters for us to understand and see what happens over the course of the season. Okay, pH, French, puissance hydrogen, or power of the hydrogen ion, right? So now we're going back to chemistry. If you take two water molecules, this is an oxygen, there's two hydrogens on it, that's what it looks like. It's like a Mickey Mouse hat upside down. You combine two of those and there's an equilibrium reaction that occurs, and you get H3O+, and you get an OH negative, or a hydroxyl ion. That's the official chemical reaction. What we're interested in here is this, H positive. So there's an OH generated and an H positive, and it's the pH measures the hydrogen ion concentration. And that's what's the reactive species and does the is of interest to us on the pH scale. Okay, so now, brace yourself, a little bit of math. Okay. So pH is defined as the negative logarithm, base 10, of the hydrogen ion concentration. Okay? If you look at this thing, this dissociates, and the dissociation constant is 10 to the negative 14. So 10 to the negative 7 go here, 10 to the negative 7 go there. The negative log 10 of 10 to the negative 7 is what? I know, all right? This is that high math. But this explains why. When you do the math on this, you take the negative log 10 of negative 7, it turns out to be 7. So when you look at the pH scale, this is why 7 is neutral. Okay? This is why I'm going through this math, to explain to you why 7 on God's green earth is neutral. Okay? If you go down this way towards 1, it's acidic, and if you go up, it's basic, towards 14. Just to give you an idea, if you had a soft drink this morning, that's around pH 2. So you're creating a pH shock to your system. We have the blood is a nice buffer system to prevent your mind from going crazy. Wine's coming around 3 to 4. Milk comes in basic. So if you have an accident, that's why in some cases they tell you to drink milk to neutralize what you just took in. Yeah, wine, right? And then if you're using lye soap or things like that, then you're getting up to 14. Battery acid that powers your car is around 1, and your stomach acid is somewhere between 1 and 2 as well. So it's very acidic in your system. Okay? Lakes then fall out. Natural lakes fall out at about 6, pH of 6 or just a little bit higher. And that's due to some dissolution of carbon dioxide that's in our atmosphere. It dissolves into rain, and it actually makes carbonic acid. And so when it rains, natural rain has a pH of 5.6. And so most lakes are just a little bit below neutral, and then you have the alkaline lakes, which are pH 9. So those are natural. Coeur d'Alene, I didn't have a chance to look at. I think you're running right around 6 something or 7 and a bit, right?
Yeah, 7.
So it's right where you want it to be. It's nice. Okay, so main takeaway here is that pH 7 is neutral. And it's because of that dissociation of water to hydrogen and OH. Okay, talk a little bit about conductivity. So conductivity is the ability of water to conduct current. So if I give you a pail of distilled water and I asked you to change a light bulb, would you do that? No. You bet. You can do that. Distilled water is a great insulator because there's nothing in it. Right? Now if I come along with the salt shaker and start shaking salt into that, would you stay in that bucket of water? That's the time you want to get out. Okay, so it's the ability of the water to conduct electricity. And if you know anything about electricity or a little bit about Ohm's law, it's just the inverse of resistance. So it's actually a giant resistance meter, and they just flip the numbers on it. They do the math for you on your screen and give you the ability to conduct electricity. Okay? And for us, that's an indirect measure of all the ions that are in the water. So that H positive, that OH negative, phosphate, all of those things are ions. And the more you have in the water, the easier it conducts electricity, and the higher your conductivity. Okay, so if you have distilled water, there's nothing in it, very high resistance, very low ability to conduct electricity. You start coming along with your salt shaker, and you're dissolving chloride and sodium ions into that. The ion content goes up, and all of a sudden it conducts electricity.
So why is that important?
Going right up.
Oh, okay, good.
Okay, so it can tell us all kinds of things about inflows, and if you're doing a profile, it shows us where you have a high likelihood of ions. Okay, now think about this. Here's a profile that I've thrown up. So depth is here, and then conductivity increases across the top. And we get this on occasion, especially in spring, where it's constant at the surface, and all of a sudden we get a little spike, and it comes back to where it was. Okay? And to us then, that's where the inflow comes in. So the inflow is usually turbid, right? You've seen the runoff here, it's like chocolate milk. That adds conductivity and it makes that water heavier. Okay? And that water then comes in and it can be warm and it will sink. Water will sink to the level where its specific gravity is the same as the water surrounding it. And it doesn't matter if it's warm or if it's cold. And then, because you have inflow and there's all kinds of turbidity in there, we get an increase in the conductivity. So conductivity is a really nice way, especially if you're in a bay, to see where your inflow is. And it could be that at the beginning of the year, you don't get any difference. And all of a sudden you get a little peak at the top, and then that peak can move down, and it can move back up, depending what is happening with the inflow that's coming in. But for us, it's a really nice way of looking at what's happening with inflows in bays. And then sometimes we have lakes where, especially when you get a lot of ions dissolved at the bottom, that conductivity profile will be like this, hits the thermocline, and all of a sudden it starts to kick out at the bottom. And that's because all that stuff's coming out as sediment and coming into the water column, and it can show us that really nicely, that there's potentially internal loading going on, or that there's all kinds of dissolved ions coming back out of the sediment. It's a very cheap measure. It's on your meters, and it's really easy to record. It's basically, the meters for this are bomb-proof. It's two little electrodes, and all you're measuring is the resistance between them. So really simple, straightforward, and can help us with interpretations.
If you actually hit the bottom, it'll spike, won't it?
Oh yeah, because you're actually diving it into the bottom. You're creating a disturbance at the bottom. Yeah.
So Frank, I have another question.
Yep.
It's been many years since I was out electroshocking, but when we sampled for specific conductivity before, putting the cathode and the anode in to shock, would we, depending on what water body, and we're in the South Fork Coeur d'Alene River, we tested it. And I can't remember if it was high or low. I think it might have been high, but we had to crank up the juice.
Then it's low.
Then the specific conductivity was
It's low. Yeah. So it's much easier to electroshock in salt water than it is in fresh water, just because the lack of ions.
Okay.
So the higher the conductivity, the easier this electroshock.
Okay, thank you.
And so fisheries biologists are really interested in conductivity, especially if they're doing some shocking. What is the conductivity, do you know? Okay, and then the other one is Secchi depth. This is probably the most expensive piece of equipment you'll take out, all of $20. And it measures the transparency. It is one of the simplest pieces of equipment that we have, and it tells us a heck of a lot. So it actually measures transparency in the water column. And plants need light to photosynthesize. So by measuring the Secchi depth, you can tell us how deep the photic zone occurs and how deep in the water column plants can photosynthesize. So we have this thing where respiration, that's what we're doing right now. We do this all the time, we respire, right? But plants have the ability to photosynthesize, and what's the end product of photosynthesis?
Sugar.
Oxygen and sugar, perfect. Right? So at the compensation depth, respiration equals photosynthesis. So there's no net gain and no net loss. So that's a magic depth in the water body for us. Above that, you have net production of oxygen, and below that, you have net loss of oxygen in the water column. So you can measure that with the Secchi depth. And that compensation depth occurs at about 1% of the surface irradiance, and that works out to about 2 times the Secchi depth. Okay, so a lot of words. So here's the graphic for that. So here's our water body, right? We have light coming into it. So that's the surface irradiance. So today we don't have a lot because it's a little cloudy, but that's the surface irradiance. The amount of light hitting the surface of the water body. And then you go out and you measure the Secchi depth. And we'll take you through how to measure that. You basically lower it until that disk disappears. And that is the Secchi depth. That's what you record. And 2 times the Secchi depth equals the compensation depth. So this zone up here is known as the photic zone. So that's where algae are able to photosynthesize, and that's where you get net oxygen production. And then below that, we call that the aphotic zone. So that's where net respiration occurs. So 2 times the Secchi depth is the magic bullet. Doesn't work perfectly, but in most water bodies, it's a very, very good approximation.
So it's a visual.
Oh yeah.
So you watch it, can't see it anymore, then you know that you've hit the Secchi depth.
That's the Secchi depth.
Okay.
And then we'll take you through it. That's the only thing you record is the Secchi depth.
We don't go further.
Oh, no. No. Well, what would you be looking for? Right?
It's really a little less than 2 times, isn't it? Because it absorbs some of the light on the upper layers.
Yeah. That's the...
But close enough.
Close enough, yes. And so here's what are the physics that occur? For you to be able to see that disk, what has to happen? Okay, you need light. And where does that light need to travel?
The disk and back up
Through the water.
There you go, right there. So the light actually has to travel through the disk, and there has to be enough for it to come back for you to be able to see it. So that's why 2 times the Secchi depth is where the photic zone, the end of the photic zone occurs. And then there's variables that come into play. So how wavy is it? How rough is the surface? And then how much other junk is in the water column? All that factors into it. So 2 times is a good approximation for that. Questions on that? So that little simple black and white disc tells us a lot of information. And man, if you could do this weekly, yeah, that would be even better, right? But now you're huge commitment. So once a month is okay. Twice a month would be, that would be my preferred way of doing it. We're going to our lake over in Oregon every couple of weeks on a regular basis.
And this is something that you'll see change throughout the season too. If you start early enough, you'll see your Secchi disk change, your Secchi depth change quite a bit based on where you are and what's in the water. But like we'll go out to Fernan Lake in the spring and you can see quite far. And then when you get an algae bloom, sometimes you can only see about, less than half a meter into the water. Whereas like up in Ponderay, you can see really deep. I can't remember what
I think it's pretty close to 20 or 30 feet. It's a long way.
Yeah.
And then Crater Lake in Oregon has got 60 feet. It's like it's just, so you can see that little disc down to 60 feet.
60 feet.
And Tahoe, it's even deeper. It's like 40 meters, so it's almost 100 feet. Yeah. Yep.
Do you have to do any compensating for Secchi depth so a lot of times you're gonna have a lot of flow and your disc won't go straight down, and so
That's why it's weighted.
even with weighted, I mean, it seems to, and I guess bays would be different, but is there any kind of,
Try and get it as straight as
try
possible.
to figure out flow and equation to get your actual Secchi depth?
No, if I have a flow issue, then I just put more weight on the disc. It needs to hang pretty well straight down.
Okay.
Is there an optimum time of day?
Yeah, so we'll go through that. So obviously, this one is really important. So right now, 10 to 4 10 in the morning till 4 in the afternoon, because the angle of incidence of the sun has a lot to do with it, right? So if you think about it, it's nice and calm in the morning, sun just rises, it's like shining that light onto a mirror, right? Your reflected light, it comes in and it just all reflects off, about 90%. I didn't think we'd get into it that deep, so I didn't bring those graphs along. But then as the sun comes up, the angle of reflectance decreases. and your angle of incidence increases, and more of that light goes into the water. So between 10 and 4 is the ideal time to do the secchi depth, okay? No sunglasses. So 5 minutes before you go to do your secchi depth reading, take your sunglasses off. Polarized sunglasses make you see that disc a long way. And you do it on the shady side of the boat. So not in direct sunlight. Shady side of the boat, no sunglasses, between 10 and 4 in the, during the day. And you lower it until you can't see it anymore. You mark the rope, you lower it some more, so you know you can't see it anymore. You slowly pull it up so you can see it again. You mark the rope, and then you take the average between the two. And we'll go through that on the dock. Okay, questions on this? Because that's the end of what I have in terms of the parameters.
Frank, for Lake Coeur d'Alene, what's a healthy depth?
For secchi? Over to you, Jamie.
I think
You have
we've
more
seen-
experience.
We've seen 10 meters.
10 meters, yeah. And then some of the bays it'll get lower. Like in Kidd Island Bay, you'd have trouble seeing the bottom at the height of the summer. And Kidd Island Bay is 2 meters deep, so 8 feet, 10 feet. So,
I have a question, so you
Yep.
should go to the same spot,
oh yeah,
always the same spot,
same spot, please.
try it.
How
Get
far out from
close.
shore?
Get
Yeah.
close. Well, so Marie's gonna talk a little bit about that, right? So pick a spot. Ideally, if you have a bay, it'd be nice to sample in the center of the bay. If you're sampling off your dock, that's all you can get. We can even make use of those secchi depth readings, but if you have a phone or a GPS and you're willing to venture out a ways, then, get the middle of your bay. That would be great. Marie?
Yeah, I'll go into this a little bit more, but we have kind of two different monitorings that we can do. One is with the more advanced equipment where we get those lake profiles, where one of us will have to come up with you because we'll bring out the equipment and we'll go out and do that. So that's the one we hope to do about once a month. And that we would go to the same location every single time, preferably kind of the middle of the bay, kind of find a deep spot and measure there. And then we have some secchi discs here that we can give out, so you can actually take one of these home. So this you could do as often as you like. You could go out and do it every hour of every day if you really want to, but just kidding. But you could go out, every 2 weeks or every week if you wanted to, and this you could do from your dock or from that same location. And I have in here I have a data sheet, and I can send out an electronic version, but this asks for the latitude and longitude so that we know exactly, and a location description. So if you have your main site that you go and monitor at, site A maybe, and you go there to measure your secchi depth, you can put that in, but maybe you also want to do it from your dock, so you can do the difference. And you could go to other areas on your bay too and compare if you wanted to, but that's where we have latitude and longitude in there so that you know exactly, so we know exactly where you were. And that's what we'll do.
Latitude and longitude, I know Google Maps gives decimals. I know in Google Earth will give the hour minutes.
It doesn't,
Which one
it does not matter.
doesn't matter?
Because we can convert them.
Convert it.
Yep. So really whatever, if people have an iPhone, the Compass app will have that on there. If you have your location services on, it'll show the latitude and longitude at the very bottom, which is really handy. Or you can go to the mapping apps, either Apple Maps or Google Maps can both give you your latitude and longitude.
Okay, then there's this, just to wrap that up, there's what's known as the Trophic State Index. And this is a really handy way of calculating, seeing what's happening in the lake over time. So if your lake, if this is a graph and this is time, and this is TSI. If you see this sort of trend in your lake, that means it's getting more and more productive. It's getting greener over time. The ideal thing you want to see is a flat line, or if you're doing some sort of restoration activity, this sort of a line. This is nearly unheard of. This is good. We have lots of lakes around there, but most lakes are undergoing this. So by measuring TSI, then this is the trophic state index of the lake. And there's 3 ways to measure that. One is with the Secchi depth. So this is where that Secchi depth reading comes in, and it's usually taken the average between May and September, the growing season. So the more readings you can get in that period of time, the better it is. And so that factors in, and then there's a TSI TP, so that's the total phosphorus that we're not doing at this point because it's the lab analysis costs. And then there's a TSI chlorophyll A. When you put all of these together, because they're all related, so total phosphorus fuels algal cells and light fuels algal cells, they're all related. And you can calculate the TSI with each one of those. And so by taking the Secchi depth, you can actually get a really nice estimate of what's happening over the course of the lake. 1 year won't make a trend, right? So the longer you can carry this on, if you're committed to this and do this for a number of years, that's what we really value in terms of data, is long-term data. And this is all part of this non-sexy monitoring, okay? But it's really important that occurs on lakes if you want to discover anything about that. And you may have, if you get a cloudy summer, you know, it may dip down, and next year it'll be up, next year it'll be down, it'll be up. And it can seesaw all over the place, right? But it's that trend line over a number of years that's really telling.
So we're committing to 20 years.
Please,
As long as I live,
please,
maybe I live that long, I don't know.
Yes, so there's no pressure to, you know, to commit for that number of years. But man, if you're interested, and when I left Illinois, we had some people that were in it for 15 years in the volunteer monitoring program, and they were starting to see some really nice trends in their lakes. And then that provided them, their homeowners association, with enough oomph to go to the state, which was still funding the Clean Lakes program back there, and to actually get a Clean Lakes program started on their lake, just because they had those data. So we really value, one, your participation, even if it's just for a short period. You know, try it out, see if you like it. But man, if you can commit and really get your teeth into this and provide these sorts of numbers and data for bays, that's really, really valuable. Yep.
So is it U of I that's analyzing the data then, or?
So we have a couple things. I will be collecting data, and we can maintain it in just a basic Excel spreadsheet and make some graphs so we can show you. We are also going to share with DEQ. They have a program called Lake Watch, which is where they put their CVMP, their citizen science data into, and so we can put it in there as well and share with the state. And then anybody else who's interested, we can provide it to them.
The beauty of the Lake Watch program is it was designed by Noel Hines, who's a limnologist. He was at the Canada Centre for Inland Waters in Burlington for 25 years. Then he left. He was originally a New Zealander, went back to New Zealand and founded this company. And he was frustrated with not being able to take multiple years of data, especially this sort of data, and analyze them really rapidly. So he and his son designed this program called Lake Watch. And with a push of a button, you can take 10 years of data and get your trophic state index just like that. So that's where the beauty of sticking it into the state database comes from. Is the analysis power of that is just phenomenal. Would you spend hours doing in Excel? It's a push of a button and it's done. The graph comes out. So it's a really nice program.
That was Burlington, Vermont?
No.
Is where he was?
Ontario.
Ontario.
Any other questions for Frank on those things? Go into the next little section
I think
here.
you gave me an hour. Just wanted you to know. If you have any other questions while we're going through this morning, then feel free to
Yeah.
ask.
There's the North American Lake Management Society for the past, I don't know how many years, several decades, has done something called the Secchi Dip-In, which means that people all over during the month of July go out and take Secchi measurements and all put their data on the Secchi Dip-In website, and you can upload your data there. And it's kind of cool. It's a way to get lots of different people involved. So since we're going into July, you could start out your monitoring by contributing to that database as well. Kind of fun. So the Baywatcher program, again, just basically a lake education program trying to provide resources to people who live there. And our goal is to hold some regular educational opportunities so people can come and take classes, but we also wanted to add the citizen science monitoring component. So the goals of that would be to collect data that can be used to protect or improve water bodies, identify potential water quality problems, and if we do, then go to the state or the tribe with those issues that we see and do some more intensive monitoring. And mostly to provide property owners with an opportunity to learn about their aquatic ecosystems that are right in front of their houses. So the data that we collect will be incorporated into that CVMP database, the Lake Watch software, to document those water quality trends over time. And as Frank said, that's really the key right here, is that time element. If we go out for one summer, you might learn a little bit, but the value really comes from regular monitoring over a course of several years. And so you don't have to commit to that today, but just something to think about, that this is part of a bigger thing. And so if you are interested in monitoring, think of it as something that you could do year after year, or if you aren't able to continue doing it, maybe we can find somebody else to adopt your site and take that on so we can get those valuable trend data. We're going to go outside and go over all these different things, but I just want to give you a quick visual of some of the tools we'll be using. The first one is a temperature logger. These are about 2 inches high maybe, and these are waterproof. You stick them in the water at the beginning of the season, and you can leave them there for months, and they will monitor at a regular interval. So you can set it to monitor every second if you wanted to, although it would run the battery down. You could do it every minute, every hour. And then at the end of the season, you can pull them out and plug them into your computer, and it'll show the graph of the temperature of your water. So we have quite a few of these, and we're looking for volunteers that wouldn't mind putting it on their dock. And we'll probably just put one per dock. And just, we have a cable we can string it on. We'll probably put it on a cinder block, at the bottom, and anchor it there, and just have it, deploy it in the spring, leave it all summer, and come back and get that data at the end of the monitoring season.
How frequently is it going to be logging temp?
So it'll depend. I think you can do every hour and have it last for, I think it was 200 and something, 240 days maybe.
Oh, wow.
So, yeah. Like I said, if
But
the
you'll
more,
have the cable from your dock coming down, so you'll have to come to this one. That's another reason.
And will you be setting it at the Secchi depth or twice the Secchi depth?
so this, because it has to be anchored to something, it'll have to be anchored to a dock, and so most of the time that's a lot less than a Secchi depth.
Yeah.
But we'll just get to put as much data as we can and see if we can find changes there. Yeah.
So I see onset there. Is this something that requires cell service?
No.
It doesn't,
No,
so
no.
it's not like the onset
There's-
weather
You
stations?
can buy ones. You can buy ones that you can check on your phone. You can just be like, oh, it's,
Like an app?
yeah.
Oh my
buy
goodness.
ones that are-
These just have a
Doing
little,
right now.
these
No, nerd.
have a little battery in them.
Yeah.
And we actually cheat over in our lake in Oregon. So we have thermistor strings. So we have them at every meter. And they're the big buoy at the top and the big cinder block at the bottom. And we have 6 of them out across the lake because we're looking for specific patterns, wave patterns. But we use exactly those little ones, and they're set to record once an hour. And it's
So then-
phenomenal data there.
We have a little base that you plug it into when you bring it back in and plug it into the computer. And so I think that we'll have plenty of time that we can actually go put one out and hold it under the water for a little while and pull it back in and find a nice, it'll probably be a graph of like before it's in the water and once it's in the water. Look at that and see what that looks like. So that's one thing that we would like to do. Again, that's really easy on your end. You just let us come out and put that out, like I said, sometime in the spring or summer. I guess this year it's kind of later, but and then come pull it out in September or October. The Secchi disc, Frank went over pretty well. Like I said, we do have enough of those that if that was something you're interested in, we can give you one, and you could collect that data and send it to me, and we can start looking at the transparency over time in your area of the lake. If you do borrow one of these, what we're going to ask is that you just rent it out for the monitoring season so that you return it in the fall, and then we can loan it out again in the spring so we can keep track of them. We also have this Van Dorn sampler. This would be for collecting water at specific depths. So we'll do a demo of this today. This would be really helpful if we could test for chlorophyll A and phosphorus, because then you can test for those at the surface and at different depths throughout the water column. And so we won't actually probably be using this until we get a little more funding to test for those samples and send them to the lab, but we'll show you how it works today. And then this is kind of the big one. It's a YSI multi-probe. So basically a 20-meter cable, and we'll look at this one just to get out on the dock, but there's several different probes in there that can measure temperature, dissolved oxygen, conductivity, and pH. And then it plugs into this handheld device, and you can actually see as those change as you lower it through the water. So we'll start that at the surface, and then slowly lower it and take down measurements as you go. And that's what creates those nice lake profiles that Frank was showing the demo picture of.
Then you roll it back up after you're done.
Yes,
I like
yeah.
And that's the one that will require you to come out.
Yeah,
to our
yes,
place
yep,
and-
because it's a little bit more complicated. This first year, for sure, we're gonna require that one of the Baywatch coordinators comes out with you to do that.
How long does that take to go through the various steps? An
Not
hour?
long, it'll depend on how deep we can go, right? So some of the bays are deeper than others, but it shouldn't takes about a couple of minutes per depth usually to stabilize.
It takes us about a half hour to do
Would that be
26
at the
feet.
Secchi sighting?
So,
or 26
yes.
meters.
So you want it at the Secchi sighting?
So we'll have, like I said, we'll kind of have one main site that we'll get the coordinates of, and we'll go out to that same site every time. And that's where we'll do this and a Secchi depth every time that I come out. So that'd be about once a month. And then, like I said, you can go out to do your Secchi depth at a different location if you wanted to. So you could do that from your dock. Or if you have a boat and you want to go out to that same location that we normally go to, you can do that too.
I use my kayak, but it doesn't,
Yeah.
I mean, it's just as easy to do.
Yeah, you can
Or
definitely
big,
do a
small.
Secchi, yeah. Yeah, some equipment that we use gets really heavy, and so if you're in a kayak, it can be kind of tippy. The Secchi disc is really easy.
Yeah.
So I would recommend, yeah. Yep. So those are kind of tools. Like I said, we'll give a demo of how to use all of them outside. But here's kind of a basic timeline. In the spring, we can provide the Secchi disc and one of those temperature loggers. And we can even come out with you and install that temperature logger on your dock if you're willing to have us do that. And then you would begin your monthly monitoring with myself or one of our other coordinators. We can work with you to kind of find a time that works for you during the month, but we'd like to maybe find, kind of stick with the same time a month for each month throughout the season. Throughout the summer, continue that monthly monitoring. And then optionally, you can measure Secchi depth more often. If you are interested in doing the YSI monitoring, those lake profiles more often, we can look into that and see if it'll fit with our schedule. See if we go out more often. And then in the fall, you'll do a final monitoring trip. We'll pull that temperature logger from your dock. You'll return your Secchi disc and the temperature logger to U of I, and then you'll submit any data forms that you have to me. We can talk about that too. It'd probably be easier to submit data forms just as you go, but if you have a bunch, then fall would be the time to submit them. And then we'd like to hold another Baywatcher meeting, bring everybody together, and provide some water quality reports at that time. So again, the water quality reports, we can provide them for the first year. They won't really have a ton of information in there. The value really comes from those multiple year samplings. So just a couple monitoring guidelines. Because I would be coming out with you to do most of this, you don't have to memorize anything, but just in general, it's best to monitor by a boat instead of from your dock, just because we do get more depth that way. So I'm guessing most people with docks, from your dock, most of the time, you would hit the ground before you reach your Secchi depth.
We're pretty deep.
Okay, yeah, so some docks are deeper, and we can kind of play with that and see, but like when we go out today, I'm guessing that the Secchi disc will hit the bottom before it disappears. So in general, if we can get a little deeper, that's better. Monitoring at the same location every time. Again, just using longitude and latitude to find that spot so we make sure we're in the same spot. Anchoring your boat so that you know that you're in that same spot the entire time you're sampling. Like I said, this, with the YSI and those lake profiles, we want it to be the exact same location. With the Secchi, because it's easy to do, and if you want to go kayak out and find 4 different sites that you want to do, then that'd be great too. But for our lake profiles, we'll be at the same spot. Yeah. So for Secchi, you wouldn't really have to, because you're doing it so quickly. It doesn't take that very long. It's ideal to monitor on calm days, because again, when you have that wind action, it disrupts it breaks up the surface of the water, makes it harder to see the Secchi disc, and it makes it a little bit harder for the probe to stabilize if your boat is swaying a lot. But we can't always control that, especially on Coeur d'Alene. And then we recommend not going out alone. Always having somebody else with you for safety. Are there any questions on that stuff? Okay. Yeah, so I think that that's all I've got. So we can go out on the dock and take some measurements, and you can get familiar with the equipment and see how all this works, how intense it is.
Marie, are you going to check out now or later?
Let's do it after. Let's come back up here. So you can leave anything that you want to leave up here.
Hey Marie, just as a follow-up from our conversation before, here's some of the estimated costs per sample. And yeah, chlorophyllate is about $75 a pop now. So that just kind of gives you an idea.
Well, you send them the bulk water. They have to filter it,
Right.
then they have to analyze the filter. And there's a cost in the filter.
The filters are the most
Yeah,
expensive.
and
They want to get like
$45.
to 0.1 micron or something, like this filter paper is crazy.
You know, like Ponderay waterkeepers, they're not doing it this year, but they were doing their own chlorophyll A, like assessing. So I mean, it's possible for programs to do it on their own.
We send ours to Advanced Eco Solutions. Is that Darren Brandt? Does he do?
Darren,
Yeah, that's Marie.
Yeah.
Yes.
So the thing, if you do it alone, like it costs me like 50 cents or a buck to do chlorophyll.
Marie, do you recommend
Seriously,
trying to
seriously.
monitor after like a rain event? If possible?
So with lake sampling, and you all can correct me if I'm wrong, with lake sampling, it wouldn't matter so much. You would just want to keep your regular monitoring going. 'Cause we've talked about doing some stormwater sampling with KEA, and that you definitely would want to go out during this season.
Sure, that's a whole
But where we're going out in the
animal.
bay, I don't think it would make sense.
Hope not.
So,
I'd say more is better, right? More sampling is better. for
Right.
sure. It's like USGS, they have very minimal sampling right now, like maybe 4 times a year, and they're missing major bell curves.
The northern lakes
There's
are
front and a back
undersampled,
on that.
woefully.
for the Secchi depths, I think go out as often as you can. But with the YSI, because I'd have to go out with it, the timing is a little bit more limited about how much often we can go out.
We might be able to tag team a little bit.
Yeah, exactly.
Sounds like a great excuse to get out on my boat. I think I want to do it. Well, I want to do it at our dock is. I'm going to see how deep it is out here.
So we're going to have some data sheets that we'll go out and fill out, and I'd like everybody to fill one out, just to get the feel for it, even though it'll all be the same data, but just to kind of see what goes onto there. So make sure to bring a pen with you. I'm gonna have a couple extras if.
You can leave your things here and we'll lock it. And I'll get the master key so we can unlock it.
Okay.
Oh.
Where you want your dummy strings, right?
So what do you think about the?
Your shirt.
Yeah, so.
What I was looking at online said that those you have in the sun.
Are you guys just going to the dock down right here?
That's my favorite place.
Oh. And I don't know, Rebecca, if you feel comfortable, but if you guys can maybe think about like sites that like if you had like your brothers
And we also
and
get
like any of these folks or us had to go out and
Oh, yeah.
monitor that we can
Target
target.
with.
Like
Just going to
Okay.
specific place.
Yeah.
Yeah, everything else finding said to do this.
It's Nancy's place in the sunset, but
Really?
Do you have an iPhone?
Oh, I did it wrong.
She got to still.
Where you guys do?
I never use my compass.
No, because we do it without.
Your compass?
My girls
get married.
You go to, App Store?
Sites and like.
Probably right, because you can see it so deep that it doesn't matter, it'll probably go through under your boat shadow. Right?
Yeah.
So,
So it doesn't matter.
I don't have a dog in the fight, you know, so I could just.
all right.
Okay.
I'm gonna go use the ladies' room.
We got all of our equipment downstairs. So you can grab your data sheet, pen, go downstairs.
and so
They are so stressed out.
Right on the corner here.
decide if I'm gonna freeze out there or not.
That's where there's no breeze. It's a little,
So if I
yeah,
freeze
a
on
little cloudier than it was.
Anyway, so they asked me to come in and park there.
Oh, okay.
Not the whole, just.
Okay, yeah, yeah. That's where we want.
Okay. I was gonna say, I was pretty sure my dogs were.
Oh, you were,
I don't know what
That's
you want to
fine.
take with you.
Oh, okay.
Okay. And I will lock it up behind you.